Hey kids. So we're reviewing. Today's our third day reviewing for the final, which will also be similar to your EOC test. Today we're going to go over the periodic table. Okay, regions on the periodic table. We'll also talk about electron orbitals. Okay, and bonding electrons. All right. Then we'll also talk about allotropes for carbon. Okay, because there's a test question from your EOC. I don't know, there might be a test question about allotropes. Okay. The last couple days, we start off with density. All right, density of irregular shaped objects, drop them in a graduated cylinder, find the density. Okay. Second day, we looked at structure of atoms, right? And ions, positive, negative ions, isotopes, how they're different by different numbers of neutrons, what the nucleus looks like, what the electron count looks like, charges, mass, things like that. Okay? Anyway, today I'm going to make a video so you guys can watch this. If you are absent, you can watch it later, right? Great. Okay, now we just did this stuff in chapter 19. This is pretty much a blank periodic table. I'm sorry, it doesn't look the best. I'll zoom in here. Right, there you go. This is what you're going to get. This is actually from one of the test questions on the EOC test, okay? They give you this, and they ask you some questions about it, okay? Or they shade in a column, like over here, and ask you what group is that, right? So let's go over this. Now, we're going to start off by taking a good look at the back cover of our table book, okay? And they got some stuff shaded in, okay? We'll start by shading these guys in. Okay, now I'm going to use this as a reference so I get the right ones. Okay, this one is shaded in. I'm shading the metalloids. Okay, that's a metalloid. Here's a metalloid. Let's see. Yeah. There's a metalloid. There's a metalloid. There's a metalloid. There's a metalloid. Okay, and then there's a metalloid. And there's a metalloid. Okay, now these guys down here are gray on the periodic table. They're recently made atoms, right? So we're not going to worry about those. Now, it's kind of important because the EOC gave you this table and it asks you something about element 1, 2, and 3 on the table, okay? 1, 2, and 3. Now, if you don't know where the metalloids are, it's pretty hard to tell what those are. Now, I'll tell you that number 1 right here is aluminum. And aluminum is a metal, okay? It would actually be considered a post-transition metal. Talk about that in a second. Okay. Element 2 would be a metalloid, and element 3 will be a nonmetal. All right. So 1, 2, and 3: metal, metalloid, nonmetal. All right. Now if they put 1, 2, and 3 here, it'd be a metal, metalloid, metalloid. All right. If they put 1, 2, and 3 here, it'd be metalloid, nonmetal, nonmetal. All right. So there we go. We've got our metalloid shaded in. Okay, those elements are your metalloids. Now, anything to the left of that is a metal. Okay, so if that was our stair-step line right through here, anything to the left of that is a metal. Right, that's a good test question. We had that on our chapter 19 test and 17 test. Anything to the right of that are nonmetals. Okay, and your metalloids are the ones that are shaded in. Now to get that, if you want a better look at it, back cover of your book. Okay. Right there, the things in green are metalloids, yellow, nonmetals, and blue are the metals. Now, the gray are, these have not been made yet at the time. In hydrogen, it's important to remember hydrogen is a nonmetal. Okay, it's grouped with the group 1 elements because it has some of the same properties as them. Okay, it's got 1 electron on the outside energy level. That's why. Okay, all these guys have 1 electron on the outside energy level. The hydrogen way over here is actually a nonmetal. Okay. Now, that'll be important, right? Where are your metalloids, metals, nonmetals? Okay, secondly, we want to go through and label some groups. There are some parts of the periodic table you need to know for your final. You need to know for chapter 19 test, which you just took. And you need to know for the EOC. So, group 1 elements are called alkali metals. And you just write that. I'm going to write it down, okay? Alkali. All right, metals. Okay, group 2 are alkaline earth. My pencil isn't working so great. Alkaline. Okay, earth. Now groups 3 through 12 on your periodic table, these guys right here, all these are the transition. We'll just write on them. How about that? Transition metals. Okay. All right. Now, those are your transition metals in here, groups 3 through 12. Okay, if I'm going to draw a red box around it, it's right here. All right. Those are your transition metals. Okay. Now down here at the bottom, these guys, okay, which is your lanthanides and your actinides, lanthanides and actinides, these are called intertransition metals. Okay, why? Because they actually go in right in there, right? They go right in here. Intertransition metals. All right. Now, there is actually what we also call a post-transition metals, which they would be right here. These would be your post-transition metals. Okay, that's aluminum. I'll put a black box around those guys. Okay, these guys down here are all made, so we'll just go up here. All right. These are your post-transition metals. All right. So let's review these real quick. Group 1, column 1, alkali metals. Group 2, column 2, alkaline earth metals. Groups 3 through 12 on the periodic table, these are your transition metals. Okay. Down here, these are the intertransition metals. And they would actually go right in here, okay, after lanthanum and actinium. Okay. Lanthanum, actinium. This would be the lanthanide series, actinide series. Okay. All right. And then we've got our post-transition metals right here. All right. We'll erase this little line here. All right. These guys are all synthetic. Okay. They've just recently been made. All right. A whole bunch of these actually. Okay. These are the ones that in your book would be in gray. Okay. They had not been made yet. All right. And then over here, these are nonmetals. Right. Now, we need to know some specific group names for our nonmetals. And, I don't know, this black's working pretty well. So let's call these guys your halogens. Okay? This group right here are halogens. Okay, that's group 17 on your periodic table. Okay, 12, 13, 14, 15, 16, 17. The halogens, group 18 are the noble gases. And again, looking at the back cover of your book will help a lot. All right, there you go. You can see that now. Sorry about the little sunspot we got over here. It's actually seeing a reflection of the projector. All right, halogens and noble gases. You need to know those, okay? So that's all the stuff you really need to know for the test for the EOC. Now, I won't test you on this, but on the EOC you might find them asking you, what is this group, that group, that group, and that group called? And they're just named after the element that leads that group. So I'm going to erase this blue thing here so you can see what it is. All right. And that would be the boron group. All right, this is boron, the carbon group, the nitrogen group, and the oxygen group. Okay. Fluorine would be right there if it's a halogens. That's noble gases. Okay, that would be neon right there. Okay, with helium above it. Okay, so this is literally called the boron group, the carbon group, the nitrogen group, the oxygen group. They are mixed groups, right? It's got metalloid metals, non-metal metalloid metals, non-metals metalloids metals, non-metals metalloids metal, right? They're mixed groups. Okay, and again, boron is a metalloid, so maybe you can shade around it. That blue would work good anyway. All right. There we go. Okay, let's pause for a second. Okay, we're back. Now what I need to talk about is, these are vertical columns, right? The vertical columns are called groups or families because they have similar properties, okay? Everything in the boron group chemically will act about the same. Okay, physically, metals versus metalloids, they'd have different properties. Okay, everything in the nitrogen group will chemically act about the same. Right? Physical properties, it's different, right? Metals, physical properties of metals, right? Ductile, malleable, shiny, which is luster, things like that. Non-metals, brittle, not shiny, right? Not ductile or malleable, okay? Things like that. Metalloids are somewhere in between. Okay. What I want to do though now is talk about the way electrons fill orbitals. Okay. You just need to know this in general. All right. So this would be period 1 on the periodic table. All right. I'm going to write it here. All right, that's period 1. Here's period 2. Here's period 3. Here's period 4. Period 5. Period 6 and period 7. Now these guys are parts of period 6 and 7. Okay, so it's not period 8 and 9. There's 7 periods in the periodic table. Now, what you need to know is that it's the outside electrons that are involved in chemical reactions. The outside electrons are what form bonds. Okay, chemical reactions form and break bonds. All right, so the outside electrons are what take place in bonding. Okay, that's what takes place in bonding, are your outside electrons. Now, you can think of these periods as being electron shells. So this is the first shell. The second shell would be here. Third shell would be here. Okay, fourth shell, fifth, sixth, seventh. These guys actually go one shell lower. So if I were to say, let's take this element, or let's take this element right here. Okay, this element right here, I'm gonna shade it in red. Okay. And let's go all the way over here. This element right here, I'm going to shade it in red. Okay, it's in the oxygen group. Okay, see that? They're in the same period, the periodic table. Okay, they're in the same row, that means the same period. What do these guys have in common? Okay, we can also pick one in here. We'll pick that one too. Okay, shade that one in red too. Now I've got 3 in the same period. We've got an alkaline earth metal, a transition metal, and we have a non-metal, right, over there in the oxygen group. Okay. What they have in common is that it's the outside electrons that take place in bonding. So electrons in energy level 4, okay, will take place in bonding in all 3 of those. All right. And in all 3 cases, there are the same number of shells of electrons, okay? Because this element has electrons in shell 1, 2, 3, and 4. This element has electrons in shell 1, 2, 3, and 4. And this element over here would have electrons in shells 1, 2, 3, and 4. Okay? They have different numbers of electrons. They will all fill those 4 shells. Okay, I could do the same thing with this one, and this one. All right? It'll be the same either way. Okay, so listen carefully. The total number of shells, all right, are the same. The number, or the shell that contains the bonding electrons is the same, because the outside electrons do the bonding. Okay, these guys up here, these other electrons don't do the bonding. All right, now, but the number of bonding electrons is different. This guy has 2 electrons at the outside energy level. Those are the 2 that are going to bond. Right? This guy has 6 electrons at the outside energy level. Those electrons will be involved in bonding. So the number of electrons involved in bonding is different. But the shell that they're contained in is the same. And the total number of shells of electrons for these guys is the same. All right. All right, guys. This is page 586 of our book. And what we're talking about are allotropes. Okay, these are allotropes of carbon. There are 3 major allotropes of carbon. Okay, same element, different structural arrangement. Graphite, very soft, uses a lubricant. Right? Diamond, very hard, used in jewelry, valuable. Okay, and then we've also got these buckyballs, Buckminster fullerene. All right, there might be a question about allotropes on your test. Just know what they are. Right? Different structural arrangements of the same element. All right, that is it. Thank you very much.